So this is the problem on the board here. I've got a sheet of paper for everybody so that you can just work through that.
To develop their confidence in problem-solving skills, these students have been given a mathematical problem to solve from start to finish. As they progress through the problem, they're allowed to ask the teacher and each other questions, and the teacher supports the students with questions and prompts.
The third problem was the pair of parabolas and them touching each other, and trying to solve that was really quite a complicated mix of problems where there were specific techniques that you needed to use to get yourself started, but then to move on, there was a little extra guidance needed in terms of how you would set up the equations for both parabolas. But in general, this was a multi-stage problem whereby I was able to put questions back to the students or just reflect what they were saying to get them to realise what the next step would be.
Some equations of the lines.
You've got equations of the lines already. How did you do that?
Well, I think possibly because you know the vertex, so by completing the square. It's different to normal exam questions. You're not really led on in the same way. You have to decide for yourself straight away how you're going to approach it.
I think it was a pretty good question, but I think the difficult part was deciding which technique to use. And then, because there's so many techniques that we would have done, trying to remember the old techniques.
I think the difficult bit wasn't the maths, it was, like they said, noticing the skills you need to use and where to apply them, maybe trial and error.
Do you know the coefficients of either the negative x squared or the positive x squared curve? That's the right answer. No, you don't. So how is that going to grow into the actual equations with some unknowns in there? How are you going to put that into your equations? The students were very quick to realise that they needed to use completed the square form, but then didn't quite get the stretching of the parabolas in the vertical plane.
The A and the B bit, obviously most of us normally would have just gone, it's 1 and -1, and then carried on, and then got along that problem later on, and then would have obviously have had to come back and work out where it went wrong.
So we've got equations for our two parabolas. How are we going to apply that to solving?
At x is 2, they have the same y coordinate because they intersect, or they touch.
Yeah. So that's one thing. When x equals 2, these are both going to be the same.
Mm-hmm.
How are you going to use that?
If they have a common tangent, does it mean the gradient on both of them is the same?
Well, what do you think? It is important to feel the success of getting through a problem through to completion, but on the other hand, it's important that they don't get stymied at a particular point through a problem, so being able to just provide those extra little prompts. And I didn't provide them with the solution, I just expanded what they'd proposed as possible solutions, just so they could see the bigger picture to make sure they covered all eventualities.
So you have the derivative of ax squared plus 2 is 2ax, and the derivative of minus b, x minus 3 squared plus 5, expands to minus 2bx plus 6b. When we found the relationship between a and b and saw that then that could progress, that was a good indicator that we'd done it right.
And this was actually a very rewarding question because it seemed quite complex to start off with, but with the various steps that they could go through, they got through to the end successfully.
I don't think it was immediately obvious, and I don't think the maths wasn't actually that difficult. It was just piecing together the parts. So once you knew what to do, it wasn't too difficult, but yeah, it was different.
We're going to need to exemplify in our teaching some problems where we are going to lead all the way through from the start to the end. But you can still structure a question, as this particular question did. There are many parts where the students can do those intermediate steps, and you just end up needing to provide the odd little pointer as they were going through.